Okay, so I want to explain how to solve this problem using the washer method to find the volume of the solid generated by revolving the region bounded by y equal 8x and y equal 4x squared about the x-axis. So the first thing we need to do is graph the picture. In order to know the best region to graph it in, we first need to find out where these two graphs intersect. So I'm going to set each equation equal to the other and solve it so I can figure out where they cross. So since y equals y, then 8x has to be equal to 4x squared. Then if I divide both sides by 4, move things around, I can rewrite this as x squared equal to x. Don't divide by x or you'll lose one of the solutions. So now I'm going to move the 2x over to the right side. This is just basic algebra. And I end up with x squared minus 2x equals 0, or x times x minus 2 equals 0, which means that they cross at x equals 0 or at x equal 2. I need the actual y values as well, so I'm going to go ahead and plug those in. I can plug them into either equation, but the easiest would be to use the y equal 8x. So when x is 0, y is 0, so this is 0, 0. And when x is 2, y is 16, so this would be the point 2, 16. Both of these are going to be, this is the origin, this is in quadrant 1, so you can see I put quadrant 1 up here, and now I'm going to graph it. Okay, so now you can see that I've just sketched out a graph here. Y equal 8x is the line and y equal 4x squared is the parabola. And I need to now figure out which way I'm going to revolve it. So I'm revolving it about the x-axis. Best thing to do is go ahead and put a little mark here. It's like a semicircular arrow that shows that I'm rotating about the x-axis. For the washer method, I need to make the strip perpendicular to the axis of rotation. So the axis of rotation, in this case, is going to be the x-axis, which, as you know, goes horizontally. So the strip runs perpendicular, and that's going to be running vertically. So the strip is perpendicular, and by that I mean I'm just going to come over here and literally draw a strip, like a rectangular box somewhere about halfway across. Now that we have the strip drawn, we need to label the differential. The differential is the short side of the strip, which would be this part right here. Clearly this is horizontal, so that's going to be dx. This is how you know whether it's dx or dy. So now that I have this here, I need to figure out what the distance is to the axis of rotation. The axis of rotation is down here. Clearly, this end of the strip is much closer to the axis of rotation than this end of the strip is. So we're going to need to make it outer minus inner. Okay, so now that we know which way the strip is going, I just want to sketch out for you a little bit what the rest of the graph is actually looking like. Since our axis of rotation is here, if I were to sketch out the mirror image of this graph across the axis of rotation, it would look something like this. So basically what we're doing is we're taking these little discs, which are like coins, like quarters, and we're rotating them. And we have an inner disc and we have an outer disc, and we're going to subtract the inner disc from the outer disc. Now they're not flat, so they're not actually circles, they're actually discs, which means they have some thickness to them. The thickness, of course, is dx. So the area of a cylinder is basically the area of a Coke can, or in this case, you can also think of it as sort of like this shape right here, which is basically duct tape. So basically, this is the outer one, and this is the inner one. And so basically what we're doing is we're going to find the area of this cylinder. So what's the area of a regular solid? Well, it's the area of the base times the thickness or the height of the cylinder. So in our case, the area of the base, well, it's a circle, so it's pi r squared, and then the height would be this distance. But when we put it this way, notice that our base switches to this side, And our height of the cylinder is actually this differential dx. And that's what gives us the formula pi r squared dx. So right here I've drawn out what a cylinder is, which is basically a Coke can. So your formula is pi r squared, the area of the circular base, times the height of the cylinder. But our cylinder is turned on its side, so our height is actually this differential dx. So now what we need to do is put this together. So if we look at our picture over here, when we're looking at it, this part right here is the inner radius, and the outer one is the outer radius. So this right here would be the outer radius. And again, we need to subtract the volume of the inner radius from the outer radius. We're basically just carving out the middle of our shape. So what we're going to do now is clearly the outer radius is coming from the line y equal 8x, and the inner radius is coming from the parabola y equal 4x squared. So let's put this into our formula. So now we have this formula, the integral pi from the outer radius squared dx minus the integral pi r of the inner radius squared dx. Now, since our differential is dx, that also tells us what the limits of integration need to be. So if we look at our picture, this region here goes from x equals 0 to x equal 2. If the differential were dy, then I would be using the y values from 0 to 16. But my differential is dx, so I use the x values from 0 to 2. So this should go from 0 to 2, and this should go from 0 to 2. Now the outer radius, well, what is the outer radius? I said it's this from the line down to the x-axis, but that's just the y value, isn't it? I mean, that's what the coordinates at this point would be. It's the y value on the line. Well, the y value on the line is 8x. So that gives me the following formula. Integral from 0 to 2. I can pull the pi outside since it's a constant, and this gives me the radius y value, which is 8x quantity squared dx, minus, again, you can pull out the pi. You could all do it in one integral. That would be fine. The inner radius is coming from the y value on the parabola down to the x-axis. So this radius is going to be the y value on the parabola, or 4x squared. And then we have to square it as part of the formula to find the volume of the cylinder. And now we have this. Now the rest of it is just basically algebra and a little bit of calculus, but the setup is here. So I'm going to pull the pi out of everything, and that's going to give me basically the integral from 0 to 2 of 64x squared dx minus the integral from 0 to 2 of 16x to the 4th dx, which becomes pi. So you don't have to see me doing all the math. I'm starting and stopping so you can see I've gotten down to the next step. Now I need to plug in the limits of integration. Obviously when it's 0, this is going to 0 out, and that's going to 0 out. So I really only need to worry about the upper limit of integration, which is 2. So this is going to give me pi times 64 over 3 times 2 cubed, which is 8, minus 16 over 5 times 2 to the 5th, which is 32. And now I need to do some arithmetic, and I'll come up with the final answer. So after a little bit of basic arithmetic, I come up with the final answer, 1024 times pi divided by 15, and that's the volume.